11.5 independent events. I can calculate the probability of independent events.
Excellent. Compound events mean more than one event. All right, independent events. Independent events do not impact other events. Everyone say do not.
Do not.
Independent events do not impact other events. Dependent events do impact other events. Okay? So really important you understand the difference between independent and dependent. So moving on down to number 2 then, we said that formula to calculate independent events would be the probability of the first one by the probability of the
second one.
And when we're talking about probability, we're talking about theoretical probability, right? Because probability means theoretical probability. Yes, no?
Yeah.
Okay. So if you look at this bag of marbles, it says in the directions here that we're going to draw a marble out of the bag and then put it back. And then do it again. And maybe again. But every single time we draw a marble, we put it back. So my question is, what's the probability you'll draw a blue and then draw a red if you put the marble back? So how many blues do you guys see in this bag?
4.
How many blues do you see in the bag?
4.
And how many total marbles do you see in the bag?
7.
So the theoretical probability of drawing a blue is 4 out of 7. So if I draw a blue and put it back, what's the theoretical probability I'll draw a red?
3 out of 7.
There are 1, 2, 3 reds in the bag and 7 total, right? Multiply them together and that is your probability for drawing a blue and then a red if you're replacing the marble. We did another one where you drew 3, self-explanatory. Then we went down to dependent events. Formula is the exact same, except for the ending. So the probability of dependent events would be A times B, right?
Yeah.
But this is the difference. B has to be calculated after A happens. And what we mean by that is, same scenario, we have the same bag, we have red marbles and blue marbles. We asked about the probability of drawing a blue. You guys said it was?
4, 7.
We got 1, 2, 3, 4 blues and 7 total marbles, right?
Yeah.
But if we kept the blue out of the bag, so in other words, one of the blues is now gone, what's the probability of drawing a red?
3 out of 6.
So before it was 3 out of 7 when we put the marble back, but now it's 3 out of 6. So we got 12 out of 42, Lavin said, and we kept reducing all the way to 2 over 7. Yes, no?
Yeah.
Cool. And then the last example I just gave you of drawing 4 reds, and eventually you ran out of reds, and you're like, it can't happen. You can't draw 4 reds if there's only 3 in there. Any questions?